Today we're learning about the electromagnetic field and the effects that it has using iron filings. And I'm over here with table 7, and look at those iron filings. It looks like they're kind of fanned out there on the sides. And Mason, does it look like the filings on the north are kind of pulled toward the filings on the south there?
Yeah.
Yeah, it looks like they make kind of a hemisphere. Let's look over here. Table 6, let's look at your iron filings here. Julia, can you describe what that looks like to me? Does it kind of look like a circle?
It does kind of look like a circle.
And Mason Crowley, can you tell me, what do the filings look like on like the north and the south end?
They look like they're coming in instead of like they're going in that way.
Yeah. Now, the Earth has a north and a south pole too, doesn't it?
Yes.
And that circle that you see that's going from one side to the other side, that's like our electromagnetic field. That's like our EM field that protects us, isn't it? Mm-hmm. Very good. And here we are with RamZland and Jada, and they're going to demonstrate what an electromagnetic field does to a glass ampule that's filled with a gas. What kind of gas is in there?
Neon.
That's filled with neon. And then RamZland, you have a machine that's going to create an electromagnetic field. What's that called?
A Wimshurst machine.
A Wimshurst machine. Okay, start cranking it there, RamZland. Good. Let's see what it does. Oh, I see the neons. Look at what it's doing there. So once it's exposed to an electromagnetic field, Jada, what happens to the gas? Yeah, it turns red, doesn't it? And Hansla, you're using mechanical energy to create a magnetic field. Very cool. And I'm here with Julia, and she's going to demonstrate how a Tesla coil creates an electromagnetic field, also using an ampule filled with neon. Go ahead, Julia. Oh, look at that. Even when it gets close, it starts to have an effect. Let's turn the light out and see what that looks like. Look at you, Julia. And even if it's not touching, it still has an effect. That is awesome, Julia. Thank you. Good job. And here I am with Medina. And Medina, we have another machine that creates an electromagnetic field. It looks like a plasmascope here. And you've got an ampule filled with neon gas. Medina, hold that up to it and let's see what happens. Oh, look at that. You're not even touching it, but it's still having an effect. That is cool. And the closer you get to that electromagnetic field, it starts to light up. That is awesome. Thank you, Medina. And I'm here with table 3. And Jenny, it looks like you've got a special device there that's filled with something. What's in there, Jenny? What are those little silver things? Are those iron filings?
Yeah.
Oh, and it looks like you've got a bar magnet inside. And we're learning about the magnetic field today. So Jenny, is there something, could you turn that upside down so we could see what the magnetic field, oh, look at that. Okay, so Jen, let's look at that. It looks like the top of the bar magnet has an effect on the filings on the bottom, but something's happening in the middle. Could you describe those filings to me, Jenny? What are they doing?
They're reaching out to something.
Okay, so the top is kind of reaching out, but in the middle it looks like some of the filings are reaching from the top to the bottom. So we know that polarity kind of describes how the North Pole there is attracted to the South Pole. If you're at the top, they just fan out, don't they? They stick out and the bottom sticks out. But in the middle, you've got an attraction. We can still see an attraction in the middle there. Great job. Thanks, Jenny. And I'm over here with table 4, and I've got Gift and Amaya. Amaya, you're demonstrating a magnetic field here with the device. What's inside there, Amaya? What is that? That's ferrofluid, isn't it? And it looks like you're using a magnet to draw the fluid up. And we know the ferrofluid is little tiny bits of iron. And we can still see, just like the iron filings, we can still see the effect that a magnet has. And if we go sideways like this, you can see that the ferrofluid still fans outward. It's still reaching out, just like it would when we put iron filings on the bar magnet. And I can see that you've got a nice drawing over here. Chase, you're drawing how those are fanning out, and I look over here. Very good. So they're fanning out there, and in the middle, they're going from north to south. There we go. Yeah, from north to south. But you can see that with the ferrofluid there, how it fans away from the magnet. Thanks, Samaya. That's. And I'm here with Fred and Medina, and they've got their iron filings that are stuck to a bar magnet that's underneath this tray. And so, Medina, could you describe to me what those filings are like? What are they doing there?
The filings are connecting to the north and south pole.
Okay, they're like the north pole and the south pole of what?
Of the earth.
Oh, of the earth. Okay. And then Medina, what about this middle part here? What about this part going to here and this part going to here? What's that like, Medina? I see kind of like here where it's going like here to here. That's really important.
Field.
Yeah, that's the Earth's EM field, right? And that protects us from what?
From getting sunburned.
From getting sunburn, right? Solar radiation. So this deflects a lot of that solar wind that we have coming from the sun. That's why you don't have to wear EF 5000 when you go outside. Your sunblock doesn't have to be super strong when you go outside to protect yourself from the sun, because you've got this electromagnetic field that's protecting you. And we can kind of see that effect right here with the filings. Thank you, Medina.